So our today topic is orthogonal curvilinear coordinate. Today topic is orthogonal curvilinear coordinates. So first we will discuss what is the meaning of these coordinates. You know that you have Cartesian coordinates. Cartesian coordinates in space like x, y, z. Everybody know about this. Okay? X means distance along x-axis, y means distance along y-axis, z means distance along z-axis. These are the coordinate of any point, are the coordinates of point say P. Is it okay? Now when you express this point, already you know that this point is in x, y, z. When you express this point, three more independent variable, say u1, u2, u3. Okay, so three independent, they are independent to each other. Independent terms, and if you can find some function which has the relation between x, y, z and u1, u2 and u3 like this, let this relation is x is equal to, there is some function say psi 1 u1 u2 u3 and another y is equal to psi 2, it is psi 2 u1 u2 u3 and let's say z is equal to psi 3 u1 u2 and u3. Means you have these three functions 1, 2 and 3. These three functions gives the relation between u1, u2, u3 and x, y, z. If you have this relation. So very much clear, x depending upon u1, u2 and u3. Y is also depending upon u1, u2, u3. Z is also depending upon u1, u2 and u3. Correct? So if you have this relation, then we can find the value of u1, u2 and u3 is equal to another function we can find pi 1 in term of x, y, z is equal to phi 2 x, y, z and phi 3 x, y, z, provided there is a condition that curl of x, y, z divided by curl of u1, u2, u3 must be non-zero. And what is this? This value is known as Jacobian. Correct? So I am repeating the whole process again. Let us suppose these three Cartesian coordinates. See it again. Three Cartesian coordinate x, y, z, and we have the function psi 1. When I will give examples, then things will be more clear to you. Psi 1 in depending on u1, u2, u3, it is equal to x. Another function psi 2 depending on u1, u2, u3 is equal to y, and similarly for z. And if this is non-zero, I will give the relation of what is the Jacobian. If this is non-zero, then we can find the value of u1, u2, u3 in terms of x, y, z. And these coordinates are known as orthogonal curvilinear coordinates. Okay? These are known as orthogonal. Now, there is a word that we have used in our relation, that is Jacobian. So Jacobian, it is denoted as like Jacobian. Like if you have a variable x, listen, x is equal to, in case of circle, x square plus y square plus r square. This is a circle whose center is 0, 0, radius is r. So you know that when you will convert into the parametric form, x is equal to r cos theta, y is equal to r sin theta. You know that? Is it okay? So when I want to convert x, y, this is the relation, means x in depending on r theta and y depending on r theta. So when you will convert x, y into r, then you need to take a value of Jacobian. So what will be Jacobian? Jacobian will be derivative of x comma y with respect to derivative of r and theta. So you can write this as determinant, see the value of Jacobian, determinant derivative of x with respect to r, derivative of x with respect to theta, derivative of y with respect to r, derivative of y with respect to theta. This is the C, x, y at the top. You have a x variable, differentiate x with respect to r and theta in the first row. Now differentiate y with respect to r theta in the second row. I will solve it. It is not very difficult, easily, only you need to know the formula. Now, you know that this is x. Is it okay? What is the derivative of x with respect to r? Cos theta. Yes or no? Okay, so what is the derivative of x with respect to theta? Minus r, because derivative of, because when I will differentiate with respect to theta, r will be constant. When I will differentiate with respect to r, theta will be constant. Getting or not? So this will be r minus r sin theta. Now derivative of y with respect to r, sin theta. So derivative of y with respect to theta, r cos theta. Now you know that how you will solve this determinant, this minus this. So r cos square theta, r minus plus r sin square theta. So r is common, cos square theta plus sin square theta is equal to r. You know that when I have converted, you know that, remember, when you have a dx and dy, you know that I have written r d, dr and d theta. So this is basically dx by dy will be Jacobian dr and d theta. Here we need to find the Jacobian from x to r theta. So Jacobian is r. You know that I have used this relation in one of the question. Getting or not? So Jacobian of when you have a variable x and y and they are depending on r theta, then you will convert x, y into r theta, then you need to convert this dx, dy in term of r theta. Then here you will put Jacobian and Jacobian is r. So this relation we commonly use. Understand? So similarly we can find Jacobian like curl of x, y, z with respect to u1, u2 and u3. So you must know what will be the formula for this. This will be the determinant of order 3 into 3. How you will write? First is x, derivative of x with respect to u1. Derivative of x with respect to u2, derivative of x with respect to u3. You are converting x, y, z to u1, u2, u3. You will take this Jacobian. So derivative of y with respect to u1, derivative of y with respect to u2, derivative of y with respect to u3. Derivative of z with respect to u1, derivative of z with respect to u2, derivative of z with respect to u3. So if you have this relation like x is equal to psi 1 u1 u2, let us suppose x is equal to u1 square plus u2 into u3. Example. Correct? So, what will be the value of derivative of x with respect to u1? 2 u1, u2, u3. Getting or not? Understand? So, value of derivative of x with respect to u2? u1 square, u2, u3. Or derivative of x with respect to u3? u1 square. Similarly, if you have other relation y and z, you can find and you will find the determinant, you will get the value of Jacobian. Is it okay? See, one more situation I want to discuss. Let us suppose you have, so resume. So see, let us suppose I have a x, y, z. See, this is very important and interesting also. These are the x-axis, y-axis and z-axis. Is it okay? So let us suppose we have a 3. u1 is a curve c1, u2 is another curve c2, u3 is another curve c3. Let us suppose I am going to take one particular area in the space. See, it is not a rectangle, I am just taking one specific area. Let us suppose this curve, this is a constant c1, c2 and c3 are constants. Is it okay? Now, let us suppose there is a curve u1. So, u1 curve, it may have anywhere like there is a curve. Here is a u1 is equal to c1. Now, this is a curve. Another curve like u2. Here is a u2 curve. u2 is equal to c2. Let us suppose there is another curve u3 like here is a curve. I am just hypothetically I am making. It is not, it will be here or it may be anywhere. u3 is equal to c3. Here is a c2, here is a c3. Now, let us suppose there is a point P. Now you know that P can be represented in form of x, y, z already. If you want to represent P in the form of u1, u2 and u3, so what you will take? You will take the tangent at this point. Tangent at u1 it will be say point is Q1. Tangent at U3, like this is a curve, this is a small curve, this is a tangent, P Q2, tangent at U2, it is a Q2, it is Q3. So these tangent, if these three tangents are perpendicular to each other, these three tangents are perpendicular to each other, then U1 curve, U2 curve, U3 curve will be orthogonal. Orthogonal means perpendicular. Orthogonal means perpendicular. So this is the situation when you will convert x, y, z in terms of U1 and U2 and U3. Then this is the situation when you will call as U1, U2, U3 are the orthogonal, just like x, y, z. Now you will see the position of P with respect to U1, U2 and U3. U1 and U2 and U3 are the new axis. Earlier axis was x, y, z. Now new axis will be U1, U2 and U3. But they must be perpendicular to each other, just like x, y, z. So these are called orthogonal curvilinear coordinates. Okay, this will be the one of the situation of orthogonal curvilinear coordinates. Okay. Tomorrow I will take some more examples, maybe I will take some question also, some more condition, unit vector, like along x-axis you have an I unit vector, along y-axis you have a j unit vector, along z-axis we have a k unit vector. What will be the unit vector along u1? What will be the unit vector along u2? What will be the unit vector along u3? Correct? Okay, so these things you need the answer of these questions. Okay, we will discuss all these questions tomorrow.